So the topic of today's video is the limitations of Langmuir adsorption isotherm. So in this video, I'm going to explain all of the limitations that are for Langmuir adsorption isotherm. So first of all, the first limitation is the ideal gas. Well, while performing the calculations for Langmuir adsorption isotherm, we have to consider that our gas is an ideal gas, means that the adsorbed gas is required to behave ideally in the vapor phase. Okay, so first of all, consider this diagram here. As you can see here, that this is the surface on which these gas molecules are going to be adsorbed, and the first assumption of the Langmuir adsorption isotherm is that these all of these gas molecules should be ideal. The gas should behave ideally. And secondly, you know that ideality of behavior is followed only under the low pressure. Why? Because when the pressure is increased, these molecules will come close to each other, and when these molecules become close to each other, there will be interactions like intermolecular forces, the repulsion, the attraction. So that's why we say that the ideality of the gas decreases when the pressure is increased. So we say that this condition can only be fulfilled under the low pressure. So Langmuir adsorption isotherm are performed, the Langmuir adsorption calculations are performed only at the low pressure. So secondly, monolayer adsorption. What is monolayer? Monolayer is actually a single layer that is being formed on the surface of this material. Okay, and you know that in Langmuir adsorption isotherm, we only consider the chemisorption. It can only explain the chemisorption. Why? Because Langmuir adsorption isotherm assumes that the adsorption is monolayer. Monolayer means that there will only be one layer present at the surface. Okay, there will not be more than one layers. So this assumption breaks down completely under high pressure. Okay, why this assumption breaks down completely at high pressure? Because when the pressure is increased, we will have the physiosorption, and in physiosorption, you know that there will be formation of multi-layer. Okay, so now the Langmuir equation is x over m is equal to ap divided by 1 plus bp. A is again a constant, b is again a constant, and p is the pressure. So when the pressure is very much low, let's just say the pressure is very less than 1. So I can take that 1 plus bp equal to 1, because as you know the value of pressure is very less than 1. So I can take 1 plus bp to be equal to 1. So x over m will become equal to ap. So x over m is equal to ap, and a you know is a constant, and I can say x over m is directly proportional to pressure. So as you can see here, when the pressure is very much low, x over m is directly proportional to pressure. As the pressure is being increased, the adsorption also increases. But when the pressure is very high, means the pressure is very much greater than 1. So when this pressure is very much greater than 1, so I can neglect this one here, and the equation will become x over m is equal to ap divided by bp. And as you know that a and b are constants, and I can write it as adsorption is directly proportional to p raised to power 0, and p0 becomes equal to 1. Something that has a power 0 has an answer equal to 1. So I can say that at very high pressure, the adsorption becomes independent of the pressure. And when the adsorption becomes independent of pressure, we will have a saturation, and that is the monolayer is completely formed. But you know, when the pressure is increased, we will have formation of multilayer, and this multilayer cannot be explained by the Langmuir phenomena, because according to Langmuir phenomena, there is just this explanation that when the pressure is increased too very much, the adsorption will become independent of the pressure. But you know that when the pressure is increased too much, there will be the phenomena of physiosorption. That means there will be the formation of multilayer. Okay, so now the third limitation is the homogeneous adsorption site. Okay, so when we are talking about the Langmuir adsorption isotherm, you have to consider that all sites on the solid surface are assumed to be equal in shape and size. Means that these sites on which the gas is going to be adsorbed are considered to be equal in shape, are considered to be equal in size. Okay, and then it is also considered that all of these sites have equal affinity for the adsorbed molecules. Well, you know that a surface is not homogeneous. Okay, the surface is not homogeneous, the surface is always heterogeneous. It means that different sites will have different affinity for the molecules, and again the heat of adsorption for each of these sites will be different, and specific surface area is also a scale dependent quantity, means that specific surface area will also be different. Well, what is specific surface area? Well, specific surface area is actually the surface area per unit mass, because as you know the different substances have different shapes, so they will have a different specific surface area, means that they will have different surface area per unit mass. And as you know, when the surface area per unit mass changes, the number of adsorption sites also changes. So this is another limitation for Langmuir adsorption isotherm. So moving on towards the fourth point, no interaction between the molecules. Well, this equation, the Langmuir adsorption equation, assumes that the molecules do not interact with each other. Okay. Well, however, this is not the case, because as you know, there are some weak intermolecular forces that are present between the molecules. So this is again a limitation for Langmuir adsorption isotherm. And the final is zero entropy. Well, this equation further assumes that the adsorbed molecules must be localized. It means that the molecules that are being adsorbed on the surface are localized, means these molecules do not move, means that these molecules are completely fixed at the position. Well, that is not the case, because as you know, the liquefaction of gases on adsorption, when these gases are adsorbed on the surface, there will be some decrease in the randomness, but the value will not be equal to zero, means the change in entropy will not be equal to zero. So that was all for the limitations of Langmuir adsorption isotherm. So if you have any question, you can ask in the comments. Thank you and Allah Hafiz.